Welcome to the Real Python Podcast. This is episode 238. Are you looking for fast tools to lint your code and manage your projects? How is the Rust programming language being used to speed up Python tools? This week on the show, we speak with Charlie Marsh about his company Astral and their tools UV and Ruff. Charlie started working on Ruff as a proof of concept, stating that Python tooling could be much faster. He had seen similar gains in the JavaScript tools written in Rust. The project started as a speedy linter with a small rule set. It's grown to include code formatting and over 800 built-in linting rules. Last year, the team at Astral started working on a Python package and project manager written in Rust. As a single tool, UV can replace pip, pip-tools, pipx, poetry, pyenv, and more. We discuss how UV can install and manage versions of Python and run scripts without thinking about virtual environments or dependencies. Charlie talks about growing the team at Astral over the past couple of years. We also discuss the funding model Astral has adopted and sustaining open source software. This episode is sponsored by Postman. Postman is the world's leading API collaboration platform, and they just launched Postman AI Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Charlie, welcome to the show.
Hey, thanks so much for having me. I'm really excited to be here.
Yeah, I'm stoked to talk to you. It's been an interesting couple of years watching all the stuff that you're working on there at Astral. Excited to dig in.
Yeah. No, it's been, I guess a lot has happened over the past, it's weird to say now, I guess it's been over 2 years since I started working on this full time.
Yeah.
Which is wild. So I keep having to remember how long it's been basically and just say the right thing.
Yeah. Well, we were just kind of talking offline before we started about working from home. And I don't know if that has something to do with the weird warping of time.
Yeah, I think it does. Yeah. I also when I started the company the same month that my son was born.
Oh, wow.
So the first 6 months, I don't really remember very well because I was I was in the hospital, fixing bugs because the project was blowing up and I was
that's wild.
So it was an interesting, the first 6 months are a little bit of a blur.
That's kind of a cool behind the scenes.
Yeah. And then we made our first hire, started growing the team in March 2023. So almost 2 years. So that's kind of more when I consider the start of Astral, the company, is when I brought on, another person. So that was about 2 years ago.
I wanted to talk to you a little bit about the company, and we'll probably dig into that a little bit further. What I wanted to do is I've been doing this with a handful of guests, especially people that make tools that everybody's using. And I'm very interested in this, being kind of a person who's entering programming late in their life. But I always wonder about how people got, not necessarily into programming, but how they got involved in open source. And do you have a story there?
Yeah. Let's see. I mean, most of my programming career, I've been more of a passive consumer of open source than an actual contributor and maintainer.
Yeah.
I mean, I think my first brush with open source was when I worked at Khan Academy, and we maintained a couple open source projects, but we also, it was the very start of my career, and I got really into React and the whole React ecosystem, and I started publishing a couple small things.
Okay.
I made a few really small contributions to React. I was maybe I should become a React contributor. And I made a couple contributions there, although I wouldn't say, anything nearly notable. And then, I was mostly, like I said, kind of a passive consumer of open source for a lot of my career until I started working on Ruff. And Ruff, it's funny because Ruff is really my first time being a maintainer. And so, and it grew really quickly. So over the course of the last 2 years, I was kind of like thrown right into the fire of like being an open source maintainer.
Yeah, I think it's a different from a contributor to a maintainer is a whole other thing.
Yeah, it's very different. Yeah, it's really, really different. And I think it's been cool to see kind of like all the different phases of a project where like at the very start, you're just like so excited that anyone would interact with it. And you're like, oh my gosh, someone cares about what I'm doing.
Look at these stars I'm getting.
Yeah. Well, when I first released Ruff, like it's not like anyone in the Python community like knew who I was or like cared about, had any reason to like think that what I was doing was interesting. So, it was just really amazing to see like people I'd never heard of before coming in, then suddenly people I had heard of coming in and seeing the project, and me being like, oh wow, like this is really kind of amazing. And then, now it's like being a maintainer now is even pretty different than it was then for us because the project is so much more popular. So now it's like, we get like hundreds of interactions a day, and it's more like, how do we keep up with the volume?
Yeah.
Like, how do we try to scale, like helping people, like answering questions and making sure they don't get stuck? How do we have to be way more thoughtful about like the changes we do make?
Yeah.
Because now anything we ship just affects a much larger group of people. If we ship a really bad bug, it might halt a lot of people in their tracks or get them or waste a lot of their time. So like the stakes get higher.
Yeah.
It just becomes a lot more work. It's just been interesting for me to go from not being a maintainer really at all to now being a maintainer on 2 or 3 pretty large projects.
Yeah.
It's been a lot to learn. There aren't really a lot of great, there's no book necessarily on how to do it.
Yeah, I like that's why I like asking the question too, is how people got into it. What was their reaction and how welcoming was the community has been an interesting kind of conversation. And this is a very interesting one because your project, like you said, has just gotten, hugely popular. And so there's a lot more traffic and things you're dealing with, and, how to continue to foster that community is always an interesting thing too.
Yeah. It's a lot of, I think a big part of the success of the project of Ruff, or at least one part of it that really wasn't about anything technical, was just that I was so excited that people cared.
Yeah.
And I spent a lot of time with people in issues, basically trying to understand their problems and make sure they had a good experience. And I actually think that had a big impact on like what the project became and the fact that it grew. It's like people felt really comfortable, at least this is what I hear and I hope, coming to the project and like opening issues and like asking for things. And like, even, the thing I often say is like, even if we say no to the thing you want, I want that person to have a good experience, and they should feel like we actually like listened and that we had some sort of rationale for why we didn't do whatever they want or whatnot.
Yeah.
We still try and adhere to that pretty closely today, even as we've like grown the team and the projects have grown a lot. And it takes a lot of time. It's a very conscious decision to be like, we're actually going to spend a lot of time talking, like helping users in issues, because it's a lot easier.
Isn't necessarily programming.
No.
These are these interesting other skills.
Yeah. And it's way easier to just close an issue and be like, you didn't read the docs, blah, blah, blah. And like, I actually like really empathize with maintainers who do that, because it's just, it's kind of a grind. It's like, every day you wake up and you have like a bunch of issues, and like we're fortunate enough that we're working on this stuff full time. So it's like I can devote a lot of time to it, and it's like very much part of my job.
Yeah.
But especially for people where they're trying to maintain a project, it grows a lot and they're doing it alongside so much else. Like I definitely empathize. It can be, especially as time goes on, it can be pretty draining. And I think for us, there's a lot of positivity in the issues in general. Like even when people have bugs, they'll often say things like, I really love the project. And that's kind of like the thing that gets you, keeps you going is
right.
But occasionally you do get people for sure who are, rude or short or, they're frustrated. And if you see that repeatedly, you see that in any project, it can be kind of a drain. So, you get energy and you lose energy in different ways. And I think for us, I just tried to make sure that as a team, we really value putting time into helping users and like recognize that within the team and such.
Yeah. I mean, the whole idea, and we'll talk a little bit more about the company maybe, but that someone can actually do it as a full-time thing. And we see that with Python itself and having these developers in residence and
Yep.
I don't know, 2 or 3 different people, and having that has just, I don't know, it's just changed so much for them. And I feel like a weight has been lifted across, Python as a language and the continued development. And then I've seen it in a handful of other people that I've talked to about this.
Yeah.
Russell Keith McGee, and he's getting help from
Right.
Anaconda, which is really cool. It's something that you can at least see movement and see these projects continue. And I think it's something that I think there has to be lots of different answers to how to do this.
I agree. I think it's actually a really good thing for Python that, I mean, people shouldn't take my opinions on Python like too seriously, because I'm pretty new to the ecosystem in the grand scheme of how long it's been around. But like, I think that I think is good is, Microsoft has a team of people working on, there's like a faster C Python team,
Yep.
which is great. Meta funds multiple people, especially working on the sort of like, I'm not supposed to call it like no-gil, but like the free threading
Right.
work.
Yeah.
I don't know. From my perspective, those companies investing in like the language and the ecosystem and kind of professionalizing the development of those things is great, because everyone benefits. And Python is just so big now that the impact you can have, even from just having like one person work full time, it's actually kind of ridiculous. Like the leverage that you could get even from having like one person work full time on some of these things.
Yeah. It's like a continuity kind of thing too,
Yeah, exactly.
What's interesting is then you coming into working on Python, and I'm not sure how long ago that was, but one of the first posts that you have, I think it was on your own personal blog that I found kind of connected there, is like Python tooling could be much, much faster.
Mm-hmm.
And I wonder about that. Why were you concerned about speeding up the tools that Python developers use?
Yeah, totally. Well, that was kind of like the blog post that launched Ruff, and it accompanied the Ruff release, the initial Ruff release, and it sort of like launched what came to be the company, and then led to UV and everything. So that was really like the genesis for a lot of this. And that feeling came from, before this, I was at a computational biology company, and I was in charge of a lot of the like software infrastructure and data infrastructure.
Okay.
And so we had like a relatively large Python code base, and I was responsible for all the tooling around it. And I was just finding that I was spending a lot of time trying to get the tooling to work for us, especially as we scaled up a little bit.
Yeah.
And even when I did invest all that time, the experience was still, I felt lacking compared to work I've done in other ecosystems. Like even in the JavaScript ecosystem, I was seeing things with tooling that like didn't really exist in Python. And the other piece to that was in the JavaScript ecosystem, there was more and more of a focus on trying to build faster tools, in part because you have all these things that happen when you like work with JavaScript. In the hot loop of your work, you need to like transpile your code or like bundle your code, or all these things that happen on your machine as you're working, and these problems that are like right in your face.
Okay.
So people started spending more and more time focusing on performance and trying to make those things fast, because they were having such a big impact on development.
Because they were like creating these like pauses in their workday.
Large applications. Yeah, large applications. And okay, every time I save, I have to wait for this thing to rebuild and show up in my browser, right?
Okay.
So in the JavaScript ecosystem, more tooling started to be written in not JavaScript, like originally in Go and then in like Rust. And they were like, it's a good investment to build this kind of fundamental tooling in a really fast language to make everyone else's work faster, was sort of a little bit of the perspective. And I was kind of left thinking, well, could we do the same thing for Python? Could we build tooling in faster, kind of lower level languages, and then let the enormous community that works with Python like benefit from that investment of trying to build tooling, in this case in Rust. And so that original blog post was really me sort of testing out that thesis of like, could we do it? Like, what would it look like? Is there a reason it's not impossible? How big would the impact be?
Yeah.
What would the trade-offs be? And kind of putting it out there and seeing if anyone cared. That was the idea, was like I built this minimal, that was the first version of Ruff. It was a very minimal linter, so it would like parse your Python code and then do some basic analysis on it, like try to find unused imports. I mean, things that Rust still does today, but that was the first version of it, much more minimal.
First set of rules or whatever.
First set of rules,
right?
Yeah. It was maybe like between 10 and 20 rules. It was, it was relatively small, but the point was I wanted it to be sufficiently complete that I could draw some conclusions about what the performance would be and like what would be hard and what would be easy.
Okay.
And so, yeah, I put that blog post out there and it got a lot of traction. People were very interested. And that's always been kind of interesting to me because I can't run this experiment now, but it is interesting to think if I had gone around to a bunch of people before even working on Ruff, and I was like, how important to you is like the speed of your linter? Like, I actually don't know that a lot of people would have said that's a really important problem for me.
Yeah.
And yet I put it out there and like, suddenly like huge projects that had been around for decades were adopting this like super new like Rust-based tool. Like I was seeing like SciPy and pandas and, and to me it was like, wow, there's a lot of demand for kind of a different take on Python tooling. So everything kind of stemmed downstream from that. But that was me trying to kind of market my work a little bit, and like try to explain to people what I was doing and why I thought it was important.
So a couple things that kind of came through that blog post and your work there are these ideas that you wanted to change some of the tools and see how the tools can change how the developers work. And you also use the term ergonomics, I think, in there, which I think is interesting. How did you see it changing those ergonomics, or was that sort of feedback that you got as people started to adopt them?
It's something I guess if I wrote it in that post, then it's something I've believed for a long time, right? But I do think about it a lot. It's kind of like if you have a tool and you make it like 5% faster, like that's great.
Yeah.
But it doesn't necessarily change like how people work or how the people use the tool. But at some point, if you make things like much, much, much faster, suddenly like the way that you use the tool can change really dramatically and your relationship to the tool can change a lot. And this is what we saw with Ruff and now with UV. Like an example with Ruff would be, I talked to people that work on Dagster, which is this big sort of a data infrastructure project. It's open source. And originally they were using a different tool and it was a lot slower. And what that meant was that people couldn't really run it locally over their code.
Okay.
And instead it would run in CI and it would parallelize across a bunch of machines. And when that happens, that means, first of all, like it takes a lot longer like the feedback loop is not very fast.
Right.
And two, also like people are pushing code that constantly fail the checks also because they can't run them locally. So they don't have a way to get that feedback.
Right. So they might just run it and never really, like you said, get the feedback.
Yeah. And then they have to fix it and push again and fix it and push again. Yeah.
Do something, actionable stuff that could have happened at that time and that moment.
Yeah. So it goes, so like at that point, your relationship to the tool is mostly like about frustration. It's like the thing that's, right? It's like the thing, it's like the concept, it's like the thing that's like getting in your way.
Yeah. Okay.
It's like, I'm trying to do my work and this thing keeps telling me no. With Ruff, they went from that setup to like a pre-commit hook, right? It can analyze like the whole code base in like 200 milliseconds or something. So suddenly it's like real-time feedback in your editor as opposed to like pushing and waiting for CI and like waiting for things to get back to you. So it's not just that it's like a lot faster, it's also like the way that you use it and your relationship to the tool just changes a lot.
Yeah.
We've tried to do similar things with UV, like with UV, and who knows if we'll be successful in these things, but like we're trying to make virtual environments, the word we use is kind of like ephemeral. No, I want to talk about that because I'm intrigued by some of the things that happen when you run it with scripts. It's like, did it install anything? Was that all in memory? What happened there? Yeah. We're sort of trying to move away from this idea of like, I have my virtual environment in this like pristine state.
Sure.
And if I run the wrong command, like it all gets destroyed and then like my day is ruined. We're trying to move away from that and move more towards tell us what your needs are for your project and we'll try to make sure that everything else just works. And sometimes we'll completely throw away and recreate your virtual environment, but the tool should be so fast that shouldn't even really affect you.
Right.
So again, it's like performance.
It shouldn't be a pain point.
Yeah. Like if it took 5 minutes to recreate the virtual environment every time, then if we were constantly removing and installing stuff, it would be a huge point of friction.
Yeah.
But if it takes 500 milliseconds or 5 milliseconds or 50 milliseconds, right? Like suddenly it's like, you might not even notice. So again, it's like, it's a little bit of trying to change how people like use and think about the tools, and performance is just one part of that. There are other parts too. Like, like in UV, we really try and push declarative dependency management. So you kind of like say what your dependencies are, and then we figure out the rest, as opposed to saying things like, install this specific package in this virtual environment. You tell us these are the set of requirements for my project, and then we'll kind of figure out what environment it needs. So it's not just about performance, but for me, that is like something that performance enables, is you can just build very different tools that would be otherwise hard to make possible.
Yeah. Well, I'd like to just, maybe we can dig in initially. I might have, again, a lot of beginners and intermediate people that come to the show.
Yeah, of course, sure.
And so they might not be familiar with Ruff at all.
Yeah.
And what it's doing and what it's potentially, I don't want to say replacing, but like, can do the job of.
Yeah, totally.
Do you want to define it for us? I'm guessing you've done this hundreds of times.
No, it's totally. So Ruff is, well, at this point, it's a lot of things, but I would say it's primarily a linter. So a linter is a tool that looks at your source code, your Python code, tries to identify problems with it. And then in Ruff's case, it can often fix them automatically. So like a good example would be, like I said before, unused imports. So if you've imported things that aren't being used anywhere, without running your code, Ruff will like look at the code and understand you imported the sys module, but you never used it. And then it can also remove that import for you.
Yeah, that might have been a change that you made that you initially went down a path and then forgot to remove it because it was at the top of your code.
Yeah, maybe you put in the sys module, and then you remove the code that used it and you kind of forgot.
Yeah.
Ruff is also a code formatter. So like it can just kind of reformat your code to have a consistent style, like similar to tools like Black. So Ruff, like one of the goals with Ruff, apart from just being fast, is we kind of try to bundle a lot of different tools into one to make development simpler. So often, like when people migrate to Ruff, they might be removing a bunch of different tools that they used before that should try to accomplish the same thing. So it's a linter, it's a formatter, and it does a bunch of code transformation, as in it fixes issues automatically for you. A lot of people will run it in their editor. Like we have various editor integrations, like in VS Code. A lot of people run it on the command line, but it can give you real-time feedback about small issues in your code and typically fix them for you automatically.
Okay, so you can choose to say highlight these problematic things or auto fix them.
Yep. Yeah, that's right. Yeah.
Okay.
Yeah. So I have my editor configured, for example, to show me diagnostics. Like it'll highlight the unused import and then fix them automatically on save. So when I hit save, it just kind of cleans up anything that's problematic. It reformats the code and all that kind of stuff.
Yeah. One of the things I thought about, because it does do so many different types of things, and maybe you're looking at getting used to this tool where somebody might have just started with a linter, then moved to a code formatter and added these things as they went and added, something like a import, tool or something like that.
Yep.
You have kind of a elaborate configuration system. How's that work? Like, how do you configure Ruff?
Yeah. So Ruff, out of the box, it enables like a small set of rules, like things that are kind of universally applicable and like mostly unobjectionable, things like unused imports. One of the goals there at least is if you run it on your project, hopefully it doesn't give you an overwhelming number of issues, because often if you take a linter and you run it on a project that hasn't used one, it can be kind of intimidating. So the base set of rules that come configured is relatively small. And from there, you can enable different categories. So like we have rules related to doc strings, like how doc strings are formatted and the information that's included in them. And again, you would opt into that. You would enable the doc string rules. We have rules related to kind of like code modernization. So maybe saying, hey, you're on a version of Python that supports a newer way of doing this. So we'll automatically upgrade your code to use that newer API or that newer syntax. And again, that's something that you would kind of turn on. So it has a lot of rules, but by default, we only enable a small set. And even when I'm doing my own work, I actually probably only enable a couple other categories. But the idea is you can kind of enable more things over time. You can also use it like just as a linter and not as a formatter, or like just as a formatter and not as a linter. Like it's kind of intended to be such that the tools work really well together, but you can also adopt them, kind of piecemeal over time.
And this is all done like in the PyProject TOML file, or
that's
the
right.
Ruff
You can
TOML
configure.
file?
Yeah, you can configure everything in a PyProject TOML file, or we have a Ruff TOML file, which is kind of for projects that don't use a PyProject TOML for whatever reason, or if you want to use like a shared set of configuration across your whole machine.
Okay.
You can put that in, in a specific directory, and we'll respect that everywhere.
So that kind of gets me to an idea here, like how this sounds like two approaches that people have done in the past of installing tools like this. They may have installed them per project, potentially, in like a development, environment or whatever, or a variety of environments, or they might have installed across their machine. This comes up a lot. I talk about virtual environments and managing, and I'm sure we'll talk about more about that with UV.
Yep. Yeah, definitely.
So you could go either path, you're saying here, with how you would, install Ruff and then manage these configurations.
Yeah, that's right. I think people generally have a configuration for the project because you might be working on the project with a bunch of other people and you kind of want to check in that set of rules to make sure you're using a consistent set of rules.
Okay.
But sometimes you might also want, maybe for example, you want a slightly different configuration for when you're working in your editor. On CI, you want to make sure that everyone's using the same set of rules and has the same configuration. But maybe when you're in your editor, you want to see certain things and not see other things. So in that case, you might set up the editor integration to look at a ruff.toml file in a centralized place.
Okay.
But in general, I generally recommend configuring at the project level.
Okay. And then as far as linting and so forth and these default choices, are a lot of those coming from ideas from other projects or from pip-8, or where does a lot of the rules that you've done come from?
Yeah. A lot of the rules come from other projects and or from pip-8 and other sources like that.
Okay.
Like our docstring rules, for example, originally came from py-doc-style, which was another tool.
Okay.
And so we aim to have a pretty high level of compatibility with those other tools. So if you're coming from those tools, it should be easier for you to migrate over. Our base rules,
you're not going to get a bunch of alerts. Suddenly.
Hopefully not. Yeah. Our base rules are largely based on Flake 8 and the rules that Flake 8 enabled, which was itself a combination of two other tools, which was pycode-style and pyflakes. This is more information than anyone needs to know, but pycode-style is based on pip-8. So some of our rules are based on pip-8, the default ones, and others are kind of correctness rules that come from pyflakes, like unused imports and such.
Well, it's interesting because you'll see a lot of these names in your documentation as you go to set up the rules. Yeah.
Yeah. I actually don't know if I want that long term. I think it's been a really good thing. I think it's been a really good thing for helping people adopt the tool and kind of, we get a lot of newcomers who will see that and be like, these words don't mean anything to me. And so it's maybe confusing for them, but we also have people who come and maybe they're coming from those tools and being able to label the rules in that way makes it relatable and easy for them to understand. I think eventually what we want though is we want Ruff to be in a world where that's a little bit more Ruff-centric, I think. You could imagine kind of recategorizing all the rules based on properties of the rules as opposed to where they come from. Maybe you want a set of rules that are about code style, and maybe you want a set of rules that are about correctness, and maybe you want a set of rules that are about performance, right? So ultimately, we want to get to that actually, which is categories that are kind of semantically meaningful.
Yeah.
And kind of also rethinking the defaults of what we include. But that's something we've wanted to do for a while. It would be obviously a big change and something we have to be really sort of careful and thoughtful about. But that is what we want to get to. Yeah, that is what we want to get to. I think it would be a lot better. It would make it a much better tool, I think.
Postman is the world's leading API collaboration platform. Trusted by over 35 million developers and 500,000 organizations worldwide. They just launched Postman AI Agent Builder, the quickest way to build AI agents. With centralized access to the latest LLMs and APIs from over 1,800 companies, plus no-code workflows, you can quickly connect critical tools and build multi-step agents, all without writing a single line of code. Start building smarter agents today with Postman. Visit postman.com/podcast/Python today. That's postman.com/podcast/Python. I talked about a recent Python tool, but it was developed by an AI company for writing basically code that can create web apps very quickly. The name is escaping my head right now, but I'll include it in the show notes.
Okay.
But they wrote their code in this truly functional programming style. It's still Python, but it would not be pep8 in any way. If you look at it, it looks really strange.
Is it fast HTML maybe? Or?
Yeah, I think that's the one.
Okay.
Yeah,
Jeremy
it might
Howard
be.
Okay. Yeah.
Yeah, it looks really different. Yeah, Howard. Yeah, exactly.
Yeah.
I don't know if you've looked at their code, but it looks really interesting.
I have looked at it. It's very interesting.
Okay.
Yeah.
So what if they wanted their rules to be in Ruff? Could they configure that?
They could probably configure like a set of rules that are compatible with how they like to work.
Okay.
So maybe those would exclude any code style rules, for example. Maybe not trying to be too specific to that project, but like, for example, maybe you'd want to like not have Ruff enforce anything about code style.
Yeah.
But there are probably like relatively unobjectionable correctness things that you might still care about. Like, again, like unused imports or like variables that are defined but never read.
Okay.
Things like that. So you can kind of configure the tool to care more about one thing or the other. But we actually kind of disable a decent chunk of the style rules by default because they're a little bit pedantic. And some projects want to be pedantic.
Yeah.
But like in general, what we want is the tool to be like helpful and not annoying. So, you can kind of, some people run Ruff with all rules enabled, which I think is kind of a wild thing to do, but some people do it.
Okay.
It's not really, Ruff is not really designed to be used that way. It's more designed for you to kind of think about what matters to your project, but some people do it.
So if someone's not familiar with the performance change with using this tool, I think we just briefly touched on the idea that it's written in Rust.
Yeah.
But what has that done for the performance of it comparatively to other tools? And I know you guys like to talk about it. So
yeah, great question. I mean, I think so. Ruff and UV2, which I'm sure we'll talk about, they're both written in Rust, and they are a lot faster than other, I think, comparable tools in the Python ecosystem. Like often that'll be 10, 100, 1,000 times faster. It sort of depends on what you're benchmarking exactly.
Yeah.
But Rust is really good for these kinds of things. Like Python is great for a lot of things. I don't know that Python is necessarily great for writing like compilers. And what we've built here, it's like Ruff isn't a compiler, but parts of it look like a compiler. Like it has to parse, like Lex and parse and analyze source code.
Right.
So look at raw Python source code and turn that into like a syntax tree that it can understand. And Rust is really fast for that. Like it's really good for text processing, for example. It's really good for things that, just have to do a lot of work that you can parallelize really well. For example, like in Ruff, we kind of like parallelize analysis across all your different files. And so Rust is really good for things like that.
So it's not always doing a top-down type of approach, which might be a classic Python style way of processing this stuff. It can actually, dig through everything, build the syntax tree, and process it across all the files.
Across the different files, yeah, exactly. So, I think Rust. Not all Rust programs are incredibly fast. Like you can write slow, like you can write slow Rust. You can write, it's similar to like in Python, you can write like fast versions. There's like a gradient of like fast to slow Python for like given a program that does a certain thing, like you could write fast and slow versions of it. It's the same is true of Rust too. Like I think for Rust, kind of like the ceiling and the floor are pretty different than in Python. Like you can write extremely fast programs. If you write like the median program, it'll be faster than if you wrote the median program in Python. Yeah. But we do spend a lot of time trying to get from like the base level of performance in Rust to like really fast Rust. And that takes a lot of work, but it's also fun. And it's really part of what we're trying to do. Like we want to build tools that are both accessible to beginners and give beginners a great user experience, but can also scale to the kinds of large and complicated projects that experts might have and that companies would have, for example. Yeah. So we're both trying to like build user experiences that are great for beginners while building tools that can scale to very large code bases and large and complicated projects.
Yeah.
I think it's even more evident maybe in UV, where we're like trying to build tools that are really friendly for people getting started, but can also scale to projects that have hundreds or thousands of dependencies. So it's like design for everyone, but build for scale. Or build for everyone, design for scale. I actually don't know which way makes more sense, but that's sort of how I think about what we're trying to do. It's like we want to build tooling that's approachable, but that also scales to experts.
One of the things I think about that you mentioned briefly there, the idea that a lot of these tools that are in the Ruff kind of category were set up as CI/CD type of things where they were only run at that moment, whereas a lot of people are running them, like you say now, in something like VS Code or PyCharm or something like that, where they, whenever they hit save, they might have this thing run and they don't even really see a performance hit, which is very much a different approach. At least that's the thing that I hear exclaimed most often about Ruff. So.
Yeah. Sort of like sometimes it'll be like confusingly fast, right? It's like, did it actually analyze all the files? Yeah. That was the thing that Sebastian Ramirez from Fast API said. I remember when he first started using the project, he was like, I thought it was broken because it ran so fast. And so I had to introduce an intentional error into one of my files to make sure that it was actually doing any work. So,
right. Or you could make a little sound effect go ding or something.
Yeah. We kind of just want like the tools to like get out of your way and not be the bottleneck in your work.
Yeah.
And we try to apply that to everything we build. I think we're not just trying to do performance. Like we also want to be solving user experience problems, right? And thinking hard about like what makes tools hard to work with, what makes for a good developer experience. But I think performance is it's one of many levers, I think, to try and build a great tool.
Just briefly, what's the preferred way to install Ruff?
With UV, but you can, which is our own project and package manager and installer. But you can also install it with pip.
Okay.
A lot of people do that because pip is obviously very popular, and it comes with Python in most cases.
Yeah.
So you can actually just pip install Ruff, or if you use pipx install Ruff.
Okay.
Again, like I said, we have UV, so you can UV tool install Ruff or UVX Ruff. Either of those would work. But basically, it's available as a package on PyPI. So you can install it from PyPI. You can install it with Homebrew. You can install it however you typically install those kinds of packages.
Okay.
I think the important thing that maybe isn't obvious on first glance is, even though Ruff is written in Rust, you don't need to have Rust installed on your machine or anything like that in order to use it, because we distribute it through PyPI as a sort of a pre-built binary program.
Yeah.
So when you install it from PyPI, we're just kind of unzipping the binary and you can run it immediately. So even though it's written in Rust, you don't need to know anything about Rust or have Rust installed in order to use it.
Yeah, it's kind of this nice benefit. It's definitely been the conversation that I've been having for the last 2 years, and definitely the tools that you guys are developing keep coming up in this conversation. But the rustification of Python tools is something you kind of keep hearing.
Yeah.
And Ruff was the buzz 2 years ago. And I would argue that 2024 was the year of UV as far as the amount of, because we do another type of show where we talk about articles and other things. And I think 2023 was all about packaging and arguing about like what packaging is going on with, and, Python's been like this forever. And then 2024 came along and UV kind of answered a lot of those ideas. And
that's cool to hear.
So that's been interesting. Yeah.
Yeah. I don't think we've figured everything out, but I think we've hopefully made some good progress on it. And
you've had lots of releases over the year.
And kind of put ourselves in a position to, I think, to like keep taking on the hard problems that we haven't solved.
Yeah.
I think, Rust, I mean, it plays a kind of like one of the beautiful things about Python for a long time has been that Python is often like, when you run Python code, you're often actually like not running just Python code. Like if you use like NumPy or SciPy,
especially
like
data science world.
Python ends up being kind of this like front end to high performance code. And like you as a user don't have to know anything about C, C++, like a blast, like all these like scary things, but you can run like vector accelerated operations or vectorized operations, like just by calling Python code. And that's kind of an amazing thing.
Yeah.
With Rust, it's similar. It's like people are building stuff in Rust. to enable people, this huge audience of people that work in Python, to work faster and benefit from it. Pydantic would be another example. Like Pydantic, they rewrote the core of it in Rust. So there you have, people are just calling a Python, installing and calling a Python library like they otherwise would. But that huge user base that Pydantic has, like the entire ecosystem benefits from, a faster, more efficient tool.
Yeah.
So it's kind of amazing that we can just like build these tools in Rust and distribute them, and everyone can just use them without having to think about the fact that it's written in Rust.
Right.
It's both, it is a source of a lot of complexity in the Python packaging ecosystem that this is possible to distribute and install native code, but it's also like a superpower and a thing that is pretty unique to the Python ecosystem that this happens. Yeah, it's been really cool to see. And like, I think Rust is a good fit for building this kind of like core tooling that, again, we kind of pay, I guess, some sort of like productivity tax because we're building everything in Rust.
Right.
But ideally, everyone else in the ecosystem benefits from like those investments that we're making at the fundamental level. Just like how much of Python itself, or much of CPython itself, is written in C.
Right.
Like we are writing a lot of the tooling in Rust in order to benefit everyone that works with Python.
Yeah, totally. I think the initial release was that February of last year. Is that right?
It was. Yeah.
Okay.
Yeah, almost a year ago.
At that time, maybe we talk about the feature set growing across that, but what was the initial release designed to do?
Yeah, great question. Yeah, so the initial UV release was February of last year, so almost a year ago. And the initial version, it wasn't intended to introduce any like fundamentally new workflows for people that were for Python packaging. It was intended to give us the foundations to like eventually do that. But the initial release was very much focused on being sort of a pip compatible API.
Okay.
So if you'd use tools like virtualenv or python-env, if you'd use pip, if you'd use like pip-tools like pip compile or pip sync, that's also a popular thing. Like those were kind of the workflows that we were aiming to replicate in Rust.
Okay.
So the initial release had like a uv-venv command to make a virtual environment, and then a bunch of uv pip commands like uv pip install, uv pip compile, uv pip uninstall. So it was kind of like you're using a pip interface, but you just put uv before it, and it works kind of the same way. That was pretty controversial, or it was somewhat controversial at the time, because a lot of people are like, why do I need to put pip? Why do I need to put pip here? Like, why do I need to do UV pip install? Why can't it just be UV install?
Yeah.
It was very intentional for us. We were like, we're going to ship a worse experience right now because we want to ship a fundamentally different experience later.
Okay.
So later that year, in I think August, we launched like this whole new set of kind of like first class APIs.
Yeah.
And that was like UV sync, UV lock, UV run. These are like the way we really want UV to be used, but they require you to kind of opt into a different way of working. So like you need to have a PyProject Toml file, and we create a lock file for you, and we do a bunch of stuff for you. So it's kind of like, if you're willing to work in the way that UV wants you to, you can use all these new APIs that should make your life really easy.
Okay.
But if you don't want to, or you can't, you can keep using the UV pip APIs, and like we'll support those forever. They're just kind of, I think of them as kind of lower level. Like when you're using those, you're saying things like, install this package into this environment, right?
Right. You're going individual piece by piece, building up your project.
It's like, create this environment, activate it, install this package, remove this package. Whereas in the world over here with UV run, UV sync, UV lock, that's more like, tell us your dependencies, and then we'll just handle it all for you.
Yeah.
So those are kind of like the two approaches that we offer. One is more of kind of manual and looks a lot more like ways that people use existing Python packaging tools. Like if you're really used to pip, you can just move to UV pip, and your experience should be the same, except much, much faster and with some other features that we have. But if you want to work in the sort of UV run, UV sync, UV lock, like first class UV world, then you get a bunch of other benefits. So that's why we did kind of the two releases. And again, the first release in February was just the UV pip stuff. So it was just like, this is a pip alternative, but much, much faster.
Yeah.
And that ended up being, I think, a really good decision because in order to ship like that, the UV pip stuff, we had to build a resolver, like a dependency resolver, a package installer.
Yeah, that's what I was thinking about.
A virtual environment creator, like all this stuff. And from February to August, when we did the second release with like UV lock and UV sync, we basically just got like UV grew a lot and we got a ton of testing. And a lot of people were using it, and we just made the resolver and the installer way, way better, in addition to building a bunch of new features.
Okay.
So, over that period of time, we could just like keep hardening and improving like that core infrastructure of like the resolver and the installer while we built this like next generation user interface.
Okay. So one of the other things that kind of got inserted in there is this way of installing Python, which is kind of between the two. I don't know if it was part of the initial release or not.
No, it wasn't.
No. Okay.
It wasn't.
Yeah. And I find that to be one of the more interesting things. And I had somebody correct me online because
I'm like fairly certain it wasn't. Sorry, now I'm second guessing. I'm pretty sure it wasn't. No, installing Python was part of the second release.
Okay.
Yeah.
Which I think is really great because that, again, if we look at tools that used to kind of do all these sort of things that were somewhat fragmented, that you'd need to be familiar with. And my 6 years or so in Python, I've seen a lot of these tools done tutorials or, spoken about things like pyenv and the sort of shifting landscape of peps and this, goal of trying to get like things like the PyProject TOML stuff. So it's nice to see all these stuff sort of coalesce into like this one thing
coming together. Yeah, it really has. Yeah.
Which is really cool.
Yeah. Like UV now actually does a lot more. Like we kind of want it to be, you install UV and it gives you everything you need to start being productive with Python. So now it's not just about being a pip alternative. It's like if you've used tools like Poetry, PDM, pyenv, pipx, like all of those all that functionality, UV can do all those things. So like you install UV and let's say you install it on like a brand new Linux machine, like a VM or something.
Yeah.
You can just clone your project and type like UV run, project file, whatever. We will figure out what version of Python you need, install it, create the virtual environment, sync all the dependencies, and run the command. Like we will do all of that for you. Like you don't need to do anything else. So it's like it's actually like really, really cool. I'm like my mind kind of still gets blown when I do it myself because I'm like, we just want to take all the complexity out of like figuring all that stuff out. So when you run UV, we download these pre-built Pythons. It's really fast. And again, you can use those Pythons with other tools. They're not like specific to UV. You can use them with anything, but UV is a way to install and manage Python. It's a way to install and manage Python tools like Black, like I mentioned earlier, or Ruff.
Yeah.
Like you have UVX, which is kind of like pipx. That's kind of run a Python application. And again, like we give you all this stuff. So it all works in one, cohesive interface. And the goal is like install UV and it should just like, again, give you everything you need to be productive with Python and take all the complexity out of wiring all these things together.
Yeah. One of the things I was intrigued by initially was like, okay, so I did what you said. I bought a new Mac Mini and I was like, okay, I have a new machine. Let me just try UV and let's try installing Python with it. And I was initially concerned because I had used tools like pyenv where I had it install Python. And then I went to do certain demonstration stuff for my job. And suddenly there were things that weren't there. There was stuff that was actually missing from the standard library, like tkinter wasn't there, which was kind of weird. And so I kind of wondered about that initially. And I said some stuff on the program and somebody tried to correct me. And so I'll ask you directly. You guys are working with these, I don't call them pre-built. I don't know what the way to think of them, versions of Python.
Yeah. I can definitely explain it. Yeah, totally. It's pretty interesting. We've taken over as maintainers of this project called python-build-standalone.
Okay.
I'll actually just kind of explain the whole thing.
Sure.
In hopefully terms that are not like too complex, but
yeah.
So typically when you build Python, not on Windows, but like on Linux and on Mac OS, a bunch of absolute paths get encoded into Python. So it's kind of hard in general to like build Python on one machine and then take that Python and like send it to a different machine and run it, because a bunch of absolute paths got encoded into Python itself. And those absolute paths might be different on the other machine.
Okay.
So in general, Python is not relocatable in that way. You can't take a Python that's like built on one machine and kind of like throw it on another machine and run it. This causes some problems because it means that if you want to install Python on your machine, like with pyenv, for example, pyenv will have to build Python from source.
Yeah.
So it downloads the source code and it runs the whole build process. Now, this isn't true for everything. Like if you install Python through like a Linux distro manager, like apt install Python or whatever, that typically doesn't have to build. And that's because in a Linux distribution, they can make a bunch of assumptions about where things are.
Okay.
So the absolute paths tend to be right. Like if you're using Ubuntu and they built it for Ubuntu, like the absolute paths in Python are probably correct.
Okay.
So
the structure is going to be the same.
The structure is going to be the same. But in general, you can't like build a Python and like send it to someone else.
Right.
So Greg Sork, a while ago on GitHub, he goes by IndieGreg, created this project called python-build-standalone that basically patches Python to make it relocatable.
Okay.
So to make it such that you could build it on one machine and move it to any other machine and just unzip it and run it.
Okay.
Those are the Pythons that we use. So they take Python head, like Python 3.13, Python 3.12, and they apply a couple patches during the build process to make them relocatable. Again, we took over as maintainers of that project. It's used in a bunch of other tools too, actually. Like if you use Python with Bazel, they use those builds. Most tools that like install Python for you, or a lot of them at least, now use this project.
Okay.
It's kind of an amazing like technical feat to take Python that's like not designed to work with relative paths and like patch it to work with relative paths. It does come with some quirks, which we've been working. That's actually been kind of a priority and still is a priority to try and reduce as many quirks as possible.
Okay.
And I think we've like significantly reduced the number of deviations over the past few months. I'm trying to remember if tk-enter is what I fixed or if I fixed TCL/TK. I have to look later.
Okay.
But that's an example. Like that's one of the quirks.
It worked today. I tried it out. I'm like, okay, it is there.
Yeah. But like basically, part of our goal has been like there shouldn't really be like we really don't want those quirks to exist.
Yeah.
And some of that is about we're working with CPython to actually like change things in CPython. And some of that is about fixing things in python-build-standalone and just making investments there. So that's a thing that we want. Like ideally there shouldn't be any quirks.
Okay.
And like that's a thing that we're trying to get rid of and spending a lot of time on.
Yeah, it makes sense.
But the upshot of all this, just by the way, is like installing Python is extremely simple because you don't have to build it. Like you just
it's super fast too.
Yeah. Like I'm on a Mac, I'm on an ARM Mac. So like it just takes it's a 20 megabyte payload or whatever, just downloads, unzips it, puts it in place and runs it.
Yeah.
It also means that like we can do things during the build process that are otherwise kind of expensive. Like we do a lot of optimizations during the build to make the Python faster that pyenv typically skips because it's kind of slow to like run that build process. But because we're just like building it once and then everyone gets it, everyone kind of benefits from that work. So yeah, we're going to be investing a lot in that because it's like a core part of how we download and install Python and I think what makes the experience good.
Yeah.
But if you do run into quirks, you should file issues so that we can fix them. Yeah, that's my only request.
Kind of similarly, maybe we can walk through some of these. Let's start with installing UV. So to get there, I had my own little drama with that, again, with my brand new Mac. And I was trying to decide which route I wanted to go.
Oh, no, yeah. Too many routes.
I ended up doing curl, which was fantastic. It worked really, really good.
Yep.
I'm not a fan of homebrew. I feel like, I don't know. I only touch it when I need to touch it. And every time I touch it, it seems to be slightly different. And there was a time when I initially really got into it in maybe 2016, 2017.
Yeah.
And they were doing weird stuff with version numbers where they were doing stuff and it broke because it was like, it never, thought that there'd be a 10, and so that ended up being like a lower number than 9. And, it's like this whole kind of thing.
Lexicographic sorting kind of thing.
Kind of goofiness.
Yeah.
So I've always been kind of like, it just seems like an oversized tool that doesn't work that great. So I don't know, what is your preferred way you would say, okay, hey, you want to install UV and start using it?
Yeah, totally. So like, we make it available everywhere, right? Like you can install it with Homebrew if you want.
Yeah.
It gets repackaged on various Linux distros, like Arch and stuff like that.
Okay.
You can install it. You can install from pipy, like you can pip install UV if you want to bootstrap the system that way, because you need some way to get UV on your machine.
Yeah.
Right. You can't use UV to install UV, so you need some way to get UV on your machine. So you can pip install, blah blah. The way that we actually recommend though is the curl script.
Okay.
So we have our own installers. Because then you don't have any dependencies. You don't need to have Python installed already. You don't need to have Homebrew installed already. On a brand new machine, you can just curl, and this is at the very top of the README for anyone who's wondering what I even mean by this. But you copy the curl command or the equivalent command for PowerShell, and it installs UV.
Okay.
The nice thing about that, besides the fact that it doesn't introduce any other dependencies, is if you install with the curl script, you can run UV self update.
Okay.
And UV can update itself. We can't do that if you install with like Homebrew or with pip, because then like someone else is managing the installation.
And you'll have to almost sort of reinstall it.
Yeah, or we have to like call brew upgrade or something. Like it's just not really like a sound thing for us to do, like mess with the install that a different tool created.
Yeah.
But if you install with the curl scripts, then you get access to UV self update. So you can just update UV at any time without any other dependencies.
Nice. This week, I want to shine a spotlight on another Real Python video course. It covers a topic we touch on this week, working with pip and installing packages from pypi. It's titled Python Basics Installing Packages with Pip. The course is built from a section of the Real Python book, Python Basics, A Practical Introduction to Python 3. And previous guest and core Real Python team member, Philip Ixeni, shows you how to install and manage third-party packages with pip, use virtual environments to separate project dependencies, declare requirements and recreate a development environment, and navigate pypi, the Python package index. Most programming languages offer a package manager that automates the process of installing, upgrading, and removing third-party packages. Python is no exception. The de facto package manager for Python is called pip. And you've been learning in today's episode about an alternative called UV that speeds up all those skills you'll be learning in this course. Real Python video courses are broken into easily consumable sections, and where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. And in this case, there's also an exercise course that you can follow along with after to practice your new skills. Check out the video course. You can find a link in the show notes, or you can find it using the enhanced search tool on realpython.com. We talked a little bit about it working as pip. And again, that command structure might take a minute for somebody to get used to having type UV, then pip. But it makes sense because there's this second verb or whatever in the commands that is able to do so many different things now.
Yep. We call it like the project API.
Okay.
It's like UV run, UV sync, UV lock. It's these commands that are all project centric. It's like I'm working in a project and I need to do X, Y, or Z.
Okay. So those, again, the standard commands there, pip install, pip show, pip freeze, pip check, things like that.
Yeah, those all exist. Yeah.
All exist. So you kind of try to mirror as much as the API as you can. A couple things about creating environments. What's like the default way that virtual environments are created?
Yeah, totally. Well, there's kind of like two ways to do it, depending on whether you want to use like the first class UV interfaces or more of the like low level UV pip interfaces.
Okay.
So you can always run UV pyenv just to create a virtual environment.
Okay.
So if you're using like the pip API, that's how you would typically do it. You'd say like, just like you would run like python-m and then like pip install flask or whatever.
Yeah.
You would do UV pyenv, UV pip install flask. If you use like the project commands, these higher level commands like UV run, UV sync, UV lock, that will manage the virtual environment for you. So it does create a virtual environment right in the directory at like .vm. So it's not like hiding the virtual environment for you or anything like that. It does just create it, but it just manages the whole life cycle. So if you just clone a new project that uses UV and you run UV run, whatever command you want to run, we will create that virtual environment for you in the right place and populate it with your dependencies. From there, you can actually like, if you want, you can just like, it's just a normal virtual environment. Like it's not like anything specific to UV. Like you can look at it, your editor will recognize it. Like it's just, that's one of the advantages of, we wanted to like innovate on certain things, but we actually thought it was pretty important to stay virtual environment centric.
Yeah.
Because so much of the ecosystem is built around it. And when you try and depart from it, things get really difficult. Like editors, like all editors expect to find a virtual environment. And so if you try and do something that's not related to a virtual environment, a lot of editor integrations break.
Okay.
So in the end, we're just like creating virtual environments, but the goal is that you don't really have to think about managing that environment. When you do UV run or UV sync, like we will just manage the environment for you, make sure it has like the right Python version, that it has all the dependencies you need.
Okay. And it's staying typically, I don't know, I want to call them local, but it's like within the project.
It's right in the project. Yeah.
Kind of the standard here. Because there are a handful of people that are fans of, managing them in different places. But would that necessarily break that?
We don't make that impossible, but we do make it hard.
Okay, it's more work.
Like sort of intentionally.
Okay.
You can set an environment variable to tell us where to put it.
Okay.
But it's actually just an opinionated choice that we think the environment, we kind of want it to, I can't believe I'm saying this, but like we want it to be like node modules.
Oh no.
Get such a bad rap, but like it's, you know where it is, you know what it is. There's no, and that's kind of how I think Python packages should be. Like I think virtual environments, they are more complex because they include like Python itself, for example, and they're kind of like linked to something else. But like fundamentally, it's kind of the same thing. It's just like the place where your packages sit for the project and that you're working on. And so we're kind of trying to, we have to be pretty careful about like where we follow convention and like meet people where they are and be flexible versus where we take opinionated stances about how things should work. And this is one area where, again, we don't make it impossible, but we do make it hard.
Well, it makes sense if your goal is to make it work in this sort of project sense. The other commands that you've added, that makes a lot of sense. The project management, that the things that are more poetry or other things like that.
Right.
If you're going to be creating a package that structurally looks like that, it's the way that we typically teach at Real Python is this exact type of methodology. Cool. So, which makes sense.
So then I must be onto something, right?
I guess, I don't know. And I do, every week or 2 weeks, I'm trying out other people's projects and, like talking about them and so forth. And so that's how I would usually build a virtual environment, just right there to try to build it. And I'm excited to have these new tools to be able to do things like run stuff. Sometimes they're as simple as a script, which is something I wanted to talk about, is this idea that you guys are using some standards that are out there, this inline script metadata. That was a fun thing to read in the documentation there. Yeah. Do you want to talk a little bit about how you guys are implementing that? Yeah,
totally. Yeah. So there's a standard that you don't need to know this number, but it's PEP723.
Yeah.
And the idea is to basically define these self-contained Python scripts.
Yeah.
So imagine a single file Python script that depends on like requests.
Yeah.
The standard allows you to define the dependencies that you need to run the script, like right in the script itself. So you have the script that needs requests, and then at the top, you basically have a comment block that says this script needs requests. And maybe also it needs at least Python 3.10.
Right.
So you put all that metadata in there. And then if you do UV run and point it to one of those scripts, we will identify that it needs that metadata, create an environment for it, and just execute the script. So you can take any of those scripts and just UV run it, and it just works. And it's really, I actually like find myself using those kind of a lot now, like in places where I would otherwise maybe like set up a project, I'll just create a script that's a single file with the dependencies declared at the top. And suddenly there's nothing else to really like think about. You just do UV run script and it just works. You can also pass like a URL. So you can pass like an HTTP URL to a Python script, and we will just like download the script, install the dependencies, and run it. It's really good for like one-off scripts.
Yeah, which is where Python really kind of initially came from.
Yeah, exactly. And like you need a dependency or two. It doesn't need like a whole project. You don't want like a PyProject TOML. You don't want a requirements TXT. You don't want to manage all this other stuff.
I want to help my coworker out and make them be able to do this thing.
Yeah, exactly. And you just UV run the script, and we should take care of everything for you. So I'm like really happy with how that turned out. Like I think the standard is good, and I think I'm glad that we prioritized like supporting it. Yeah, we also recently shipped some news. You can also, this part I think is really, really cool.
Yeah.
We have some commands in UV for modifying your Pi project toml.
Yeah.
So you can do like UV add requests or whatever, and we'll add requests to the Pi project toml.
I totally wanted to ask you about this because I was just playing with it.
Yeah. So you can do like UV add -- script, and then the path to the script, and then requests, and we'll actually like add that metadata block to the script and add requests to it. So it's actually pretty hard. Like the syntax, I mean,
it's a little funky.
It's a little funky. There aren't that many great options, honestly.
It's not standard Python style, but yeah.
It's kind of a hard design space, but like it's just hard to remember exactly what the syntax should be.
Yeah.
But now it's like the way that I work, if I want to create a script, is we also have UV init. So I do UV init -- script main.py or whatever.
And it adds that top block for you.
It adds the block, and then I do UV add -- script main.py requests, TQDM, rich, like whatever I need for my script. Just adds that stuff there, and then I start writing the script, and then I just do UV run and pass the path to the script, and I don't even really think about like managing the dependencies. So I'm really happy with that workflow.
Yeah, that stuff's right in your documentation, and I was able to play with it. There's like a rich example and a request example there that are pretty short, but like I think hammered it home pretty well to me that I was like, okay, yeah, I'm really excited about this. And where this also came up recently is I had Akshay Agrawal on to talk about Marimo. I don't know if you're familiar.
Oh yeah, totally. Yeah, I know Akshay. Yeah,
and he is so.
Yeah, they use this stuff kind of a lot too.
yeah, they love it, and I was like, oh, that's interesting. And I was trying to figure out how they're using it and so forth. So that again gives that ability. In this case, their notebooks are kind of like a script. They're a singular file.
Yeah, it's serialized as Python, right? Yeah.
Yeah. And so it's another way that you can kind of, if you have UV installed, you can get up and running pretty quick with those notebooks.
Yeah. So like, if nothing else, I think UV is worth worth using for that.
Yeah.
Because it's like, I don't know, people really love it. I personally really love it for my own work. And it just makes it just takes all the pain out of like building and running a Python script. And like, you could also, again, you could take that script, drop it onto like a random new Linux VM, install UV and just UV run it. We'll install Python, we'll run the script, we'll do it with all its dependencies. Like we just want to it's a good example, I think, of we just want to make all that stuff really easy.
Yeah. So we've touched on it a couple times, this idea of doing things that like pipx used to do. I did a whole episode about tools. And so pipx came up quite a bit there. And you have the command UVX or UV tool.
Yeah.
I guess those are interchangeable.
Yeah. UVX is the same as UV tool run.
Okay.
It's kind of shorthand for that. Yeah.
Okay. And in that case, you can install, is it kind of anything that is pipx installable?
Yeah. Anything that's executable.
Okay.
So like, Black, the project Black or Ruff, right?
Yeah.
Those are kind of different than like Pydantic. Like Pydantic is like a library that you import.
Sure.
Black and Ruff are tools that you execute. So like that's where you would do.
You might have it across your system.
Yeah, exactly. And so you can type UVX Ruff. If you just go to a random project and type UVX Ruff format, UV will download Ruff and run the command Ruff format over the project. So it's a way to manage tools. That's why we use the word tool. We think of them as tools that you might install like across your machine. Like I'm going to use Ruff in a bunch of different projects, so I want to install it with UV tool.
Okay.
UVX is just shorthand because it's a lot to type UV tool run repeatedly. So like I mostly actually do like UVX Ruff format for my own projects, for example.
Okay. And that is installing on your system wide so that you can then, when you go to run it again, I mean, not that it takes long to install it, but it will be installed and run on that installed version.
Yeah, pretty much. I mean, it basically like if you do UV tool install, we will install it globally. So you could do like UV tool install Ruff.
Okay.
And then you can just run Ruff without UVX because we just put it in your path. If you do UVX Ruff, if Ruff is already installed, it will use that. Okay.
If not, it just puts it in memory.
It just it caches it.
Okay.
And it kind of refreshes it periodically. Like if you ran it across 2 days, we might check for updates, for example.
Okay. And that's true of some of these other ways that things can be installed, especially the script style usage.
Yeah, the scripting stuff is like we basically cache the dependencies in the environment. Yeah.
Which is kind of wild. Like, you run this code and you're like expecting it like, okay, it populated in my virtual environment, right? It's going to be on my machine. And it's like, no, it's just
Yeah.
cached.
Well,
Okay.
you can go find it if you really need to, but
Okay.
hopefully for the script, you shouldn't need to.
Right.
Yeah,
Okay.
it's stored in our cache. We basically create these environments and we reuse them over time.
Okay. So it is there.
Yeah.
It's just, yeah. Okay.
Yeah, it does exist on disk. Yes.
Yeah. But it's not like something that's so much project facing, if you will.
Yeah, exactly.
Okay. So then on the project management side, I feel the documents are pretty good for like people like, okay, you want to just get started with this idea. The initial command is like an init command. Is that right?
That's right. Yeah. Yeah. So we have commands like uv init will just kind of like create, scaffold a basic new project for you. You can uv add to add dependencies. And then we do have commands. We have like uv lock, which resolves your dependencies and creates a lock file.
Yeah.
And then uv sync, which installs from the lock file and populates a virtual environment. But you can also, if you want, like just forego those and use uv run, because uv run will automatically do things like check if the dependencies are up to date, check if the environment is in sync with like what you asked for. So you can just clone a project and do uv run, and we will like make sure that the lock file is up to date, as in it shows the exact versions of every package that should be installed, make sure that the virtual environment is up to date with the lock file, and then run the command. So, we do have these like uv lock and uv sync, which is like resolve and install,
right?
But it also happens for you automatically via uv run if you want.
So the difference would be if you're, building a project and, kind of, creating and populating everything inside the PyProject.toml file versus like if you're just consuming a project or using a project, then you can just use run, which is great.
Yeah, that's right.
Okay. Well, I don't want to dive, into command level things on each one of these things, but it's really kind of amazing.
There's a lot
what's
there.
in there.
Yeah.
There is, yeah. And I feel like the documentation's, really good. There's nice examples, get people up and running and playing with a lot of this stuff. A couple things that we touched on that I wanted to hit on before I let you go, because this project is twofold. It's a little controversial in the Python ecosystem, and I'm sure you've seen some of this back and forth about it. Some of it is about, okay, these tools are built in Rust. Is this really supporting the ecosystem? I think we've hit that pretty well. We've talked about like, this is another step along with speeding up code. There's been a lot of that underlying, especially in all the data science tools. Python itself is built under C. So I don't think we need to hit on that too much. But
right.
Part of it is you guys are kind of a slightly different answer by creating this business of Astral.
Yep.
And you're taking funding from VCs, which is different. Do you want to talk a little bit about that and your decisions?
Yeah, totally. So yeah, we've talked mostly in this episode about Ruff and UV, but we build those as part of a company called Astral. There's 12 of us working full time on open source, which is great. Like everything we built so far is open source. Obviously very very permissively licensed. The choice to build a company is a different one than a lot of people take to open source, but I think there's a lot of different ways to look at it. One is we've brought a lot of basically resourcing into the Python community. Like we're able to have 12 people, hopefully more soon, that are working full time on like open source MIT and Apache licensed Python tooling, which I think is great. But our goal is not to like monetize the tools themselves. Like we're not looking to charge people money to like use Ruff or UV. I think a lot about like what I want obviously I think a lot about our strategy as a company,
sure.
But I also think about like the incentive structure that the strategy connotes.
Okay.
So like our strategy is instead to build and sell, and we have not done this yet, but build and sell software that integrates well with our tooling and competes with things that people already typically pay for.
Okay.
Like people don't really pay for like a linter or like a package manager. We're not trying to like charge people money for those things.
Right.
But we might, we've thought about, for example, building like a registry, a package registry. A lot of companies have like their own internal package registries to either mirror PyPI or pull in host their own packages.
Right.
The companies that build those are selling security features. They're selling a lot of different things. We could build, I believe we could build, a really great registry.
Yeah.
And maybe it integrates with UV in certain ways while still being fully standards compliant. So that's just an example for me of like, we have a bunch of companies that we spend time with that use our tooling.
Yeah.
And it would be a pretty natural extension of what we build today to say, hey, we also offer a registry. Would you consider purchasing that? Right. And et cetera, et cetera. So, I don't know that we'll actually build that specific thing. I'm not trying to like suggest that that's exactly what we're going to build.
Right.
But it is, I think it does exemplify the strategy, which is like, I don't want us to get into a position where we're like, again, charging people money to like use the tools.
Yeah.
What I want is like, we build the tools. That's like an ecosystem of stuff.
Right.
And hopefully it keeps growing. Hopefully people really like it. It enables us to spend a lot of time with companies because a lot of companies use this stuff and they want us, and frankly, they want us to try and solve more problems that they have. They want us to do more things that they struggle with. We can understand like the problems they have with like building with Python, shipping Python, using Python in production, all those kinds of things.
Yeah.
And then I want us to go and build, solutions to those problems. And again, that compete with things that people are typically pay for, but that integrate well with our open source and are kind of, the phrase I often use is like the natural next thing you need when you're using Ruff or using UV. Like, what are like the second or the next problems that people have when they're working with Python? That's it's actually an extremely wide space of things we could build, which I think is really cool. And that's kind of what we're going after. But, it's a very different, I admit, like, it's a different approach to building a company. I've also been on the other side of these kinds of relationships, right? Like
you started that with the tooling, right? And
I've been a programmer like my whole career. Like, I've used tools that are venture backed. I've seen tools go wrong. I've seen tools go right. I mean, I've also seen tools that are not venture backed go wrong, or disappear, or teams get unfunded from large companies too. Maybe their priorities shift.
Projects imploding. WordPress, anyone right now?
Yeah, there's like, there's tons of like, there's tons of ways that things can go wrong. And like, of course, things could go wrong for us too. Like, I want to build a great and sustainable business here.
Yeah.
To no small degree in service of trying to build a better Python ecosystem. Like, the more, like, if we succeed as a company, then like, I think, obviously I think this, but hopefully it's believable. Like, it's good for the Python ecosystem because we can put more resources, like R&D, basically into building great stuff for the ecosystem. So I want to build a great business. Obviously, it's hard for us to predict what's going to work and what's not, but that is at least how I think about the incentives of what I want, which is I want us to be incentivized to build great tooling. And I don't want the tooling to be competitive really with the paid offerings, if that makes sense. Like, for a lot of companies, that I think if you're not careful, that can become true. Like, the free thing that you offered, the freemium thing that you offer is kind of in competition with the paid offering.
Right.
I want us to have a slightly different incentive structure, but that leads to, just a different model. Like, I want us to have the tooling and then the paid services that kind of integrate with the tooling. And
that makes sense.
Who knows if we'll succeed? Like, I'm going to do my best to make sure that we do.
I see how that works with companies very often, how they want, I mean, that's kind of Tidelift and other organizations like that. These companies want a voice in the tools that they're using and have some kind of connection that way. And so I kind of see how that continues, and the repository thing is a really common thing, this idea of having a way to keep certain parts of your code private is important, and so that all makes sense to me.
Yeah. And like, I care a lot about keeping our projects and like our identity to like truly open source. So, hopefully, I think it feels that way to people, and, we'll keep on building things under very permissive licenses. We also have a lot of like open source DNA on the team. Like, pretty much everyone on the team that we've hired, I met or discovered through open source. And like, pretty much everyone on the team has been or is a maintainer on some other big, maybe not big, but some other open source project. Like, it's just a lot of how we work. So, like I said, we can't predict the future. Like, who knows where we'll end up building, but like, this is at least how I think about like the strategy and like why start a company here. Like, there's just so much impactful work to do, I think. And I really believe that like the Python ecosystem, I mean, it's the largest or second largest programming ecosystem on earth. All these companies are using Python. And I think there are lots of opportunities to, hopefully like build a great business, and then we can keep feeding that back into building a better Python tooling and a stronger Python ecosystem.
Yeah, that totally makes sense to me. I want to be respectful of your time.
Oh, no worries.
There's lots of other things that I would like to talk to you about, kind of roadmap stuff. So maybe I'll come back to talk about more like, what you're planning for Ruff and UV in the future. But I do want to touch on one thing that you've been hinting at a lot lately that has to do with type checking. And I know that this is really, really new.
Yep.
I don't know how much you can talk about it, but that is something you're exploring.
Yeah, no, happy to talk about it. I mean, we're building a static type checker for Python.
Okay.
So for people who have used tools like MyPy, or Pyrite in the past, or present, I guess, we're building basically an alternative, our own kind of from scratch type checker in Rust.
Okay.
Performance is a big focus, as are some other things. Like we want it to be a great type checker in a lot of ways, but we do want it to be really fast.
Okay.
That's kind of where a lot of our sort of like new product energy is going right now, is like making that.
Okay.
It's all happening in like through open source. Like the development is in the Ruff repo right now. So we've been working on this for a while, but we've been pretty quiet about it because we didn't want to draw too much attention to it before we really like had anything to show.
Sure.
It's still, but people have been following along. And I actually remember like the project is codenamed Redknot, which is a type of bird. And it's just like super, super random name. But like when I went to Eurorust in November, I gave a talk, and then after the talk, a bunch of people were coming up to me, and people were randomly coming up to me and asking me about, like, they knew what Redknot was. Like, we hadn't announced it or anything, but they'd been following the repo and seeing the PRs and seeing the issues and stuff. And I was like, oh gosh, okay,
I was in here and I spotted something new.
Yeah, exactly. So some people have been following. We've had a good amount of contributors too, but I just decided to start talking about it a little bit publicly. It's still not at a point where we really want people to be using it. Like, it's not like you should go try it on your project and then report a bunch of bugs, because we know that things aren't done. So like people who are interested in contributing, like that's obviously welcome, and they might want to test it out and see what the kind of issues are, but it's certainly not at a point where it's ready for user testing.
Okay.
But we obviously have big ambitions for it this year. So we're kind of working right now towards what we think of as like an alpha release, basically. And for us, that's something that we can actually start running on real projects to prioritize what we want to do. Like right now, it's like there's still a couple of really critical things missing that make it so it doesn't really even make sense to run on real projects. But like that's what we're trying to. That's our current milestone. Is like an alpha that we can actually run on real projects, and then we can say, okay, these are the small things we're missing. These are the things we need to improve. So we have some really amazing people working on it, like Carl Meyer, who joined us from Instagram. He was working on Cinder, which is like Instagram has their own fork of Python, or Meta has their own fork of Python called Cinder, that's performance focused and makes some different decisions to run Python at very large scale. So Carl joined us, which is great, because otherwise I would think I certainly have no idea how to build a type checker. So him, Alex Waygood, who's also a CPython core developer and the maintainer of the Python typing module and TypeShed and typing extensions and a bunch of projects like that. So we built up a lot of like great Python expertise, and then we've kind of combined that too with, and this is one of the cool things about our team, I think, we've kind of combined that with people who don't even really come from a Python background, but come from backgrounds in other programming ecosystems, or maybe they're really good at Rust, or maybe they're great at building programming language tooling. So we kind of bring together and I mean, Carl and Alex are also great at a lot of those things too. They're not just Python or anything like that. But my point is, we just bring together, I think, a lot of really talented people. And for me, it's intentional that some of that is like people who really understand Python, and some of it is like people who have totally different perspectives. And kind of bring them all together. So it's been really cool. It's kind of the first project that, well, maybe not the first, but it is one of the first project. Well, is it the first? Just trying to think. I guess it's kind of the first project where like I'm really not very involved in writing code.
Okay. Yeah, I was going to ask you a little bit about that. Yeah.
I've contributed a little bit, mostly so I can get familiar with like what's hard, what's easy, how do the abstractions work, like all that kind of stuff. But it's really mostly driven by the team, and I help make decisions if I'm called upon.
Yeah.
But it's just really cool to see it kind of coming to life. So it's really early. It's going to take a lot of time. People will probably be mad at us by the end, because they'll be like, I just never
looking at their watches. I don't know.
It's just the thing that I've been asked for more than anything else by like an order of magnitude over the years.
Yeah.
I know people are really eager for it, and I just wanted people to know that we're working on it. We're committed to it.
I would say it's a pain point out there of the current tools. You guys have a habit of building tools that people are excited, if you will, to use. That's a weird thing to say. Like, these are the tools that I use and that I'm excited to use them. Sometimes it feels like that can be against, fighting against each other.
Yeah.
So.
Yeah. I mean, look, it's a very complicated piece of technology. I think it's like, from a technical perspective, it's probably the hardest thing that we've tried to build.
Okay.
The existing tools out there do a good job. Obviously, I still think we wouldn't be building something if we didn't think that we could hopefully build something really good and compelling for people.
Yeah.
But it is definitely a hard set of problems, but there's a lot of demand for it, and I'm hoping that we can deliver on it. So that'll be a big focus for us over the next couple months and I'm sure years. But hopefully we'll have something to show sooner than years.
Yeah.
Yeah, I'm glad you asked about it, because it's been something that we're really excited about, and it's just cool to see the community response to it.
Well, I'll have to have you come back and talk more about it when it comes along. And I'd also like to talk to you a little bit about what it's like to become more of a manager.
Sure.
Less, like how much coding you get to do. And then you've written a lot recently about not being a fan of the typical code interview process, which hiring, which I think might be interesting too.
Yeah.
So these are all things we could discuss at a later date if you're interested.
Thankfully, I've kind of like engineered my schedule such that I actually still do get to write quite a lot of code.
Good.
But obviously less than maybe I was when I first started the company.
Sure.
Most of my development time, though, is focused on UV right now.
Yeah.
So, but we should, I guess I'm also, have a lot of other responsibilities on top of that.
Yeah.
So it's a little bit of a mix.
I like to ask everybody who comes on the show a few questions. And the first one is, what's something that you're excited about that's happening in the world of Python?
Well, definitely our own type checker. No, I'm kidding. I think I actually sort of touched on these earlier in the show, but I think it's great that there's a healthy focus on performance in Python itself now, like with the faster CPython team, the JIT that they're working on, the no-GIL, the free threading work, that stuff. There's also this whole other class of like sub-interpreters. Like some people know about this, some people don't. It's like a little bit niche, but there's just a lot of exciting like threads coming together, I think, in Python. And it will take some time for this stuff to really be, the impact of this stuff to be clear and obvious. But I'm like I feel really good about the fact that like those investments are being made. So basically Python being faster over time, I think is a great one.
Yeah. So what's something that you want to learn next? This can be programming or not programming.
I'm going to make it programming. I actually don't even know if I'll like actually have any time to do this, but a funny thing for me is like, I don't really come from like a systems programming background. Like most of my career was Python, TypeScript. And then I started learning Rust, like shortly before I started to work on Ruff, but I've never written any like C++. I mean, I wrote a little bit of C in college, but like, for a course.
Sure. Yeah.
But there are a lot of other like ideas in systems programming that like I'm kind of interested in exploring in other languages, really. Like I'd like to better understand like some of the things that are hard about C++ that Rust tries to solve.
Okay.
I think Zig is also pretty interesting. That's another programming language that's been growing a little bit. It's still quite early. It's not out of 1.0 yet, but I kind of want to like spend time looking at other approaches to solving these kinds of problems, just so I can better understand what I like and don't like about Rust. I really enjoy writing Rust and I feel very productive, but I also feel like I haven't seen like this whole idea space of like different ways to think about managing memory, for example.
Yeah.
So hopefully having time to explore those things.
It's a common answer here from especially like the core developer people that they like looking at other languages.
Yes. Yeah.
And thinking about how those things come, like Brett Cannon's brought it up a handful of times that he's come on the show that it's like, well, this does this in this other language. And so, I think that's fascinating. What would be the best way that somebody can follow your work online?
Yeah. So I post a lot on X And then I cross post on Blue Sky. So like those are probably the best. I mean, you can also follow me on GitHub, I guess, but like that's where I post the most like content is on X and on Blue Sky.
Okay.
So it's just Charlie R. Marsh on both of them. So
cool.
First name, last name, and my middle initial, which is R.
And then as far as like all the different tooling and so forth, should they all head to Astral?
Yeah. You can go to docs.astral.sh. That'll take you to the homepage. That'll send you to either the Ruff or the UV docs. It's also obviously on GitHub. So just like github.com/astral-sh/UV or /Ruff.
Okay. Well, Charlie, thanks so much for coming on the show. It's been fantastic to talk to you.
Yeah, thanks for having me. I appreciate all the great questions. And it was great to have a chance to meet you too.
And don't forget, Postman is the world's leading API collaboration platform. And they just launched Postman AI, Agent Builder, the quickest way to build AI agents. Start building at postman.com/podcast/Python. I want to thank Charlie Marsh for coming on the show this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.